Good day, everyone. Welcome to Master Edge Academy. Today, we're going to plot a plan using bearing and distances. We're going to talk about disclosure, how to apply correction, and the labeling. Alright, before we start, this is an example from a practical done by Footer. So, they did a practical using theodolite and they got this bearing and distances over here. So, we're going to plot them using AutoCAD or Civil 3D. What I'm using here is Civil 3D, but it has the same interface with AutoCAD. So we start. When you first of all open Civil 3 AutoCAD, this is how your interface will look like. So for space purpose, I'm going to remove some of all these things so that I can have enough space. Okay, so the first thing you do when you first open CAD is you come here, come to Home. So you come to File, Drawing, Utilities, Unit. You set your unit. There is a shortcut to that, but I like using the long cut so that you will never forget it. Come to Direction, choose Notes, OK, and OK. Alright, now you are set. So what will you do? First of all, you come to Home. Under Draw, you click on Polyline. Click it and you press anywhere in the system. Just click anywhere. So the first thing you first do, like what I wrote here, is to input the from GPS 1 to A, the distance, that is 196.6. Then you press Control less than, that is what is here, Control less than. It will give you the space to put the bearing and distance to the bearing. So you put 275D 07 minutes, D in small letter, D 07 minutes 25.37 seconds. Enter. Alright, so you can zoom out so you can see where your line is. So the next one is 61.3, then shift less than, put your bearing 274 degrees 08 minutes 54.15 seconds. Hit enter. Alright, so just anywhere you put it doesn't matter. So your next one is 102.27, that is distance meters, then shift less than, then we have 13 degrees 51 minutes, then 54.44 seconds. Hit enter. Alright, so your next one is what? Yes, 60.87 meters, then shift less than, and 106 degrees 05 minutes 30.22 seconds. Enter. Alright, so the next one is 59.91 meters, then shift less than, then 170 degrees 59 minutes 32.51 seconds. Enter. Alright, so the last one, because they started with GPS 1 and they're ending with GPS 1, you understand? This is how it goes. Alright, the last point is 170.30, that's then shift less than 105 degrees 22 seconds, then 22 minutes 31.05 seconds. Enter. Right, now you can escape. Press escape. Now look at the issue here. This is the work. Now this is the issue here. Disclosure. We started with at this particular point and we're ending here, because when you're working with bearing and distances, there is always issue there's always the issue because it will not end at a certain point. So in surveying, there are methods we try out to do. There are methods we use so that it can end at this particular point, that is applying correction. But in this practical, we'll not apply correction, we'll just leave it that way, because our major aim is this plot here, which we need to apply correction first. But assuming we have applied correction, let's just assume we have applied correction, then it's not time to label it. Alright, before we label it, let's bring this thing back. Let's bring this one back, and let's bring our properties back. Alright, so I'll come back to home. I want to put line here, so I change the color so that at least we can know our major land, our major plot. Sorry, so from here somewhere here. Yes, so this is our plot, but we started from here actually, because this is our known point. So because you start from whole to part, these are our known points, and we went back and ended here. Right, so it's time to label the work. To label in Civil 3D is simple, but in AutoCAD, I guess you have to do it manually. But Civil 3D, come here, come to add. Alright, so line and bearing, line and curve, multiple segments, and you set these ones because you set it to the normal method. You press here, just follow. Then you press here so that you can enter, you apply, you can see it. Alright, so it's time to set the distance to 2 decimal place, enter, then you can put M. I usually put M so it will just show as distance. Apply, okay. So it's time for me to add. Alright, so can cancel this now. This is our bearing and distances, so you can see exactly how it is. This from here to point A is 275, which is this same size shown here. The same, this is from A to B, B to C, C to D, D to NN1, NN1 back to GPS1. So this is the way we plot bearing and distances using AutoCAD or Civil 3D. Now in our next video, we are going to plot using the coordinates. I have done it already, but we are going to plot using the coordinates. Now if you are plotting through coordinate system, the work is going to close because you have done so many corrections with it, and they have done the calculations, they have applied corrections to it using formula. And so where you are using coordinates, this particular closure you are seeing here will not be there because it will not close because its coordinate is point. So your job is just to join all the points together. So you can see, so disadvantage with bearing and distance is that it will not close. You have to apply the corrections to make it close. It will not close. So this is the disclosure. And I guess using the formula method, you can use various different methods to still close this work. But if you don't know the method, there's a way you can apply. You can close it like this, applying circles and doing this and this and this so that it can close. But all the same, thank you very much. In our next class, in our next tutorials, we will use the coordinate method and see the differences we have in bearing and distance, because there will be differences, yes, but it will be slight differences. We are having 2275 degrees 07 minutes 25.37 seconds. Now when in our coordinates, we might have a slight difference in this particular place because of the correction that was made. So coordinates, bearing and distance will be different. The bearings will be different, but the distance will still be the same, or okay, maybe slightly different too, but all the same. This is how you plot using bearing and distance. Thank you very much. See you next time.